Alright, in this first topic of term 2, we're going to be talking about differentiation. We're going to recall a little bit about what you've learned in paper 1, basically, right? You learned chain rule, dy over dx equals to dy over du times du over dx. We're going to use this heavily. Product rule, the u prime v plus u v prime formula, quotient rule. If it's a division between two functions, then it's u prime v minus u v prime over v squared. Yeah, and you also learn a little bit about the application of differentiation in paper 1. Yeah, the fact that dy dx is a gradient, and then if dy dx equals 0, you get a stationary point. Dy dx is less than 0, you get a decreasing function. Dy dx greater than 0, you get an increasing function. All right. So on top of that, you learn a little bit about second derivative. Yeah. The application for second derivative is, you will get to determine the nature of the stationary point, whether it's maximum or minimum. Yeah. If the second derivative is greater than 0, that's minima. Less than 0 is maxima. Let's just try to solve a few things first. Yeah. For example, this one. Find the derivative if y equals to 3x squared plus 5 to the power of 100. Then the best way to do this is by using the chain rule, right? I mean, you have your inner function, you have your outer function. Your inner function would be 3x squared plus 5. So if you differentiate that, then you would get 6x plus 5, the constant is 0. And then the outer function would give you 100. You drop down the 100 of 3x squared plus 5 to the power of 99. Yeah. And then you just basically kind of like simplify this. And you'll stop here. Okay, the second example. Yeah, looking at the question, it looks pretty much a question where you should answer it using the product rule, because it's the multiplication between two functions here. So you use the product rule to find the derivative using this formula. U prime would be 15x squared. V is, well, itself, plus, what's u v prime? U is 5x cubed. V prime is the same as their first question, right? So that's going to be 600 x times 3x squared plus 5 to the power of 99. And that's about it, basically. I mean, if you want to simplify it a little bit more, you'll get a 15x squared times 3x squared plus 5 to the power of 100 plus, that's going to be, what's 6 times? That's going to be 1,200 of, what am I doing? That's going to be 3,000 x to the power of 4 times 3x squared plus 5 to the power of 99. And that's going to be my final answer. Next up, we're going to, extend the paper 1 differentiation a little bit with the introduction of exponential. I mean, for those of you guys who's learned additional math, this is a lot easier for you. But for those of you guys who haven't learned additional math, I mean, this is something that you need to know. This is actually the most important property, one of the most important properties in mathematics. The derivative of e power of x is itself, basically. If you would like to know the proving of this, then I'll save up a link there, for the proof later on. Okay. So based on that, let's try to solve a couple of examples. Like, for example, how do you solve e to the power of 7x? To differentiate e to the power of 7x, all you need is to, well, in all the cases of exponential functions, you focus on your power. Yeah. What do you do with it? You drop down the derivative of 7x. So it's gonna be there. Yeah? And the rest of them will stay the same. Let's look at another example. Yeah? So you focus on x squared. How do you derive x squared? Well, x squared is equals to 2x, derivation basically. And then the rest you just basically copy. See here? Another example. E to the power of x cubed plus 2x minus 1. How are you going to be able to do that? Well, again, first thing that you should do is to differentiate the power, and then you drop down. So you'll get a 3x squared plus 2 here times e to the power of x cubed plus 2x minus 1. Okay, so this comes from the derivation of x cubed plus 2x minus 1. Last but not least, yeah, well, this is the same as, yeah, if you're comfortable with this format, go ahead, yeah. So this will give you a, well, you find the derivative of this first, yeah, find the derivative, you drop down. The derivative of that would be half times 5 minus x squared times negative half times, to the power of negative half, I'm sorry, times negative 2x, right? And then you will use e to the power of square root of 5 minus x squared. Simplify it further, you'll get something like negative x over square root of 5 minus x squared e to the power of square root of 5 minus x squared. Okay? Again, when you're doing exponential, the first thing that you need to identify is the power. All the powers. Yeah? Yeah. Once you've identified the powers, you derive it, you drop down. Okay? All right. An example of some application here. Yeah. Find the derivative if at y equals to this. I mean, looking at this, you should be able to know that you're going to be using quotient rule because it's a division between two functions. So you let this as your u, let this as your v, right? So to find the derivative, you will use u prime v minus uv prime over v squared, right? So, I mean, it is not too difficult, right? So u prime, that's going to be 7 times 2x minus 5 power of 6 times 2, right? V is, well, it's going to be e power of 3x. Is this plus or minus? Let's just make it as 3x minus 1. Yeah, minus 1, right? And then minus, what's your u? U is 2x minus 5. The whole thing raised to 7, right? And then v prime. V prime is how do you differentiate v here? Yeah, so you'll differentiate v, well, you use the same way, right? Focus on the power, you derive the power, and then you drop down. So in this case, you'll get a 3e to the power of 3x minus 1. Because 3 here comes from the derivation of 3x minus 1. Okay? And once you're done with that, then don't forget the denominator. There's v squared there, so it's going to be e to the power of 6x minus 2. Question number 2, it's more of an application question. Yeah, it says find any stationary points of the graphs of y equals 2x power of minus e power of x and determine whether they are maxima or minima. Well, I mean, to solve this, you must use some concept in paper 1, right? It says find any stationary points, meaning that you need to use dy over dx equals 0 because that's where it says it's stationary, right? And then number 2, to determine whether they are maximum or minimum, this is the same as to find the nature of the stationary point. Yeah, the same thing, whether it's minimum or maximum. So you have to kind of like, do a second derivative later on. Yeah. Okay, so let's try this real quick. Yeah, you got y equals to 2x minus e to the power of x. So your dy dx, the first condition is has to be equal to 0. So therefore, right? So this is gonna be 2 minus e to the power of x, right? Because, well, obviously, the derivative of e power of x is itself, right? Then that's gonna be equal to 0. So e to the power of x, that's equal to 2. Right? And then ln e power of x equals to ln 2. So x equals to ln 2. So when your x is equals to ln 2, then you will get a, well, y equals to 2 times ln 2 minus e power of ln 2 y is equals to 2 ln 2 minus 2. Yeah. So the coordinates of the stationary point would be ln 2, comma 2 ln 2 minus 2. Yeah. So that's your x and that's your y right there. Okay, we've tackled the first question. The second part says that you want to determine whether they are maxima or minima based on the stationary point that you got here. Unfortunately, we only have one stationary point here, so d squared y over dx squared is equals to, well, you refer to this, you will get a, well, that's going to be minus e power of x. Okay? So check whether minus e power of x when x equals to ln2 gives you a positive or minimum. Yeah? So at x equals to ln2, yeah, d squared y over dx squared equals to what? That's going to be negative e power of ln2. That's going to be negative 2. And therefore, that's going to be smaller than 0. So therefore, it's maxima. Yeah? Based on the information that you learned in paper 1.